Hey, welcome back to another .NET video. I might start calling these .NET Adventure, or maybe Adventure and .NET, because honestly, making these videos sometimes can be an adventure because you just never know what you're going to run into in the code. So I have a couple APIs that have stood up locally. I have my car data API as well as my engine data API. They're pretty bare bones APIs, and I have a local RabbitMQ instance running. Just pulled the Docker image and started that. And I have some queues and exchanges made. And I want to show you one quick thing before I get into the code. I want to show you this endpoint I have here to post data to that RabbitMQ queue. So when I hit execute, it's going to publish to the exchange that then gets routed to this queue. And you're going to see the message spike to 3. And so this queue does not currently have any consumers. And so I want to show you something that is going to be what we're talking about in this video. So I'm going to go over into my car data API, and I have a consumer registered to listen to that queue with MassTransit to get those messages. So I'm going to set a breakpoint on this here. And again, I have 3 messages in the queue. So when I start this API, it's going to immediately fetch or retrieve those messages. So I'm going to debug this. I have a breakpoint set on data, and I'm going to show you what happens when it runs. So it's immediately going to get called here. And if I hover over this, you can see that the message has horsepower and test, which is what I sent from Swagger right here. So everything looks good. And again, I have 3 messages, so I would assume I can step over this 3 times, and it's going to be 3 messages. And I'm logging it to the console. And if I go to my console output, you can see that. Let me start this. There we go. You can see that I have 3 tests that get logged. But the thing about it is it gets processed sequentially, meaning it fetches one message, does everything, and then acknowledges that message on RabbitMQ. Once the acknowledgement is sent to be okay, it then retrieves the next message, and then so on and so forth. So it retrieves a single message at a time, and if those acknowledgements all get sent back to be okay, back to RabbitMQ, then that message is going to be removed off the queue because it's just reading a message from a queue is a destructive action. And so this seems fine, and it makes sense in our context. We have connection between my engine data API and my car data API with messaging. So we have an event-driven architecture here. If we want to use messages to trigger methods, if we want to use messages to trigger, whatever we want it to trigger. But this is in the context of really a low throughput environment. We're not sending too many messages. We're not doing a whole lot. And if I go back to my car data API and, let's just say I, send another message through, it's going to go and process. And this is a functional system. This will work in a lot of use cases. And we've done a number of diagrams on this channel describing this architecture and describing the benefits of this architecture and what adding a message broker into your system and using queues, what that can do for your system as a whole. But what I want to talk about in this video is, what do you do if it's a high throughput system? What do you do if we need to process multiple messages at the same time, or really as many as we can, basically more than one message? And this is not, it doesn't have to be the case all the time, but sometimes you want to send things in parallel. Sometimes you want to do multiple things at the same time or near the same time. And so when you think about in .NET, you think about, okay, we can spin up new tasks. They'll be added to the task scheduler. We can do, we can await those. We can do task.winAll and fire those off, depending on how many threads or processor cores we have to work with. And obviously we're at the mercy of .NET's task scheduler, but what if, that'll work well and we can take advantage of .NET's TPL library or whatever else we want to use. But if in this existing system, we're only ever going to get a single message from RabbitMQ at the same time. If we wanted to consume multiple messages at the same time, we'd have to introduce more queues, we have to register more consumers, and we can do that, and that would also work. But I'm going to show you a way where you don't have to do that and just leverage something that's already built into MassTransit. So I'm going to stop my car data API, and I'm going to come again into my consumer class, so engine queue consumer. You can see that it inherits from type I consumer, and that's part of the MassTransit namespace. And all we need to do, and again, this is very powerful because it's so easy. All we need to do, instead of just the message, we need to wrap the message in batch. And if we hover over batch, it says that it defines a class that is consumer message, and it allows, oh, okay. So I thought that was for batch. Batch basically means it's going to get multiple, up to 10 of this message. So what I'm going to do is now come into the actual implementation, and I'm going to do the same thing here. So batch context, or consume context, batch, and then finish that wrapper there. And now it's set up. And what we have to do now is this gets up to 10, so retrieves 10 messages max at a time. And so if you think about having multiple messages, you're going to think about, okay, we probably need a for loop, or you can use a for each. So I'm just going to call it, for data in our context, which is what the parameter is here. And if I do context dot, you can see I have a couple options here. And the option that we want is going to be message. And you can see that message is a type batch engine data queue. And if we drill into that, we can see that now I can copy and paste this code and put it inside my for loop. And if I remove, I have to call it something else other than data. Actually, we probably don't need that variable now. If I drill into data, you can see that my option now becomes data.message like it was before. And data, and then I get the properties name and horsepower, so we can do name. But I want to show you, so now I have this structure here set up. The next thing I need to do is, because I don't have any messages in the queue and I want to simulate, what it would be like to consume multiple messages at a time, I'm just going to send a bunch of messages to the queue and just give them different names here. It really doesn't matter what I name these. I'm just going to send a bunch of them. All right, let's go back into RabbitMQ. Let's wait like 5 seconds, and let's see how many messages I posted. Okay, so I have 13 messages. That'll work perfect. And if I go back into car data API, again, this is set up to be a batch consumer, and I set a breakpoint right here on my for loop. And I just want to set a breakpoint here because I want to see what the context is now. So I'm going to debug this, and my breakpoint is basically going to be immediately hit, and you can see that it's hit here. So I'm going to drill into context and see what that is. So now context, if I go into message, if I drill into this, you're going to see that now. You can see that if I expand the results, it's going to enumerate the results. So I'm going to basically step into this here. So if I drill into my message, you can see that now the data is there. But if I drill into the whole context and I go into message, and now I want to enumerate the results, you can see that I have all the messages. I have 10 messages in this collection. So this is very powerful, because if we have data that we can process concurrently, we can do that within the context of this consumer now. And obviously I'm not doing it right now, but I just want to show you how you can set this up to process data concurrently. And again, it's crazy because I added a batch and batch. And that's all you have to do. And so it's super powerful. Again, if you, this isn't right in every scenario, but if it makes sense in your context, then you can get a lot of power out of this style. And you can see that it fetches 10. So then it fetched the remaining 3. And if I go into my console, you can see all those get logged in my console. And so again, you could think about it. If I was, wanting to spin up a task, right? I could just say like, var, I'm just going to make stuff up, equals new, task. Obviously it's not task dot. Let's see. I think I have to do task factory dot start new, maybe. Do we have to get, I think it's going to make me. All right, let me go to the bottom of this, and I'm just going to make a I'm not going to, okay, just print async print to console. Now I'm going to do console dot write line. And then I'm going to give it my string. Sure, I'll take autocompletes message. Okay. All right, so now var task is equal to it always is a lot harder. Coding our task okay. All right, now we got here. So now let's loop through those. Again, this is extremely rudimentary approach, but I'm just showing you autocomplete's killing me. I'm just showing you a real rough thing that you can do. Async print to cont data and message. Okay, did I data, what is the, I don't know why Rider does that. It doesn't autocomplete. It gives you the option. I'm used to it taking the first option in that list, but then it proceeds to do the autocomplete thing anyway. So okay, so now last thing I need to do, task.win all tasks, and I need to await that. Okay, we finally did it. All right, so now we're here. So this is extremely rudimentary example, but I just want to show you batch processing of the data coming from RabbitMQ. All we have is just a real basic method, async method. We're going to print to the console, and we're going to do that as in parallel as we can. We could do a parallel.forEach. We could do a data pipeline. We could do a parallel for loop. We can do a lot of things, but this is just what I'm doing here. So again, we need a lot of data in the queue. So let's go ahead and just spam data into the queue and just give it random values so that our log statements look a little bit different. Let's give it a lot of values. All right, how many do we have? We probably have enough. 18, that sounds good. All right, so now we have 18, and I have a breakpoint. Well, I basically don't have a breakpoint set. I have it set at the end. So I'm gonna let this run, and I am going to pull up the console window if I can expand this open. There it is. Okay. Let's let this run, and let's watch the console, and we should get all of our messages. And boom. Okay. There it is. All right, so now that was 10. You can see like that. Okay. So now I'll set a breakpoint there just to show you the tasks, right? I'll continue. We should get 8 more tasks. Yeah, we have 8 more tasks. So we're going to do tasks.win all, and then we're going to complete the tasks or await the tasks. And we're going to log a lot more messages to the console. And if we come back to my queue, you can see we have 0 messages. And that is a very rudimentary example of batch processing in MassTransit with RabbitMQ in .NET. So again, this doesn't fit every scenario, but in potentially a high throughput scenario or a scenario where, somehow your queue is getting backed up, because this is also, it doesn't fit every scenario, because, the whole thing with queues is you always want to be at 0, right? Your queue should always be at 0. Presumably, if you have a functioning system, if that's how it happens, if your consumer is always, let me go here. Let me go into. If your consumer always has a connection, right, to RabbitMQ. So RabbitMQ uses connections, basically, or channels. So what happens is that when we create a connection, RabbitMQ makes a channel, which is basically a virtual TCP connection to the server. So assuming you have a live channel, a live connection, your queue should always be near 0, because your consumer should be keeping up with your producer. If for some reason your consumer is not keeping up with that, or you have a scenario where you don't have a consistently running consumer, you may need to introduce batch processing. But again, you may not have to, because if you have a bottleneck in your consumer, you need to. It should raise questions as to where is the bottleneck on your consumer. What is it about that data being consumed? What is happening with that data that is forcing us to have this bottleneck? Do we need to break off logic and maybe add additional queues to separate out that logic, so we're not introducing a bottleneck on the queue? Because again, a queue should be at 0 in a healthy and functioning environment. And so again, this is just one way you can do this with batch. Like if you have some scenario where you need to process messages like this, again, it's not for everything, but again, I just want to show you what's possible with RabbitMQ and MassTransit, and if it fits your scenario, then it fits. So again, there's a number of ways to do this. You can mess with the, there's a lot of configuration. You can mess with the prefetch counts. You can again mess with multiple consumers, because another way to look at this, right? We have one consumer that's connected to the queue. What you could do is introduce additional queues and introduce additional consumers to that data. You could get, if I go into my exchanges here, let me just jump back into RabbitMQ. So the exchange that is those messages are being routed through is this engine queue. And if I go down to the bindings, you can see that the queue is bound to that exchange. If I introduce another queue, I have a number of options I can make this. If I want to do a queue, I can give it routing keys. I can make it, I can get any number of things that can dictate where those messages are routed to, assuming it's, some kind of, like in this example, it's a fan out exchange, so it wouldn't abide by these. But if it was a topic or headers exchange, then I could get more granular in terms of what I'm routing the messages by. What key am I routing it by? And then if I have additional queues, and I could register again additional consumers and process the data that way. And so again, this is just, and it gets more complex if you have multiple instances of your application running. And so in RabbitMQ, you have an idea of a single active consumer. And so if you introduce batch processing, you just have to make sure that you're still abiding by that rule and you don't get duplicated messages. But again, a lot of configuration. This is just one feature set that you get out of the box with MassTransit if you're using RabbitMQ as your message broker. So I think it's pretty cool. It's, again, I really think that it's really valuable if you're a developer to just have like a lot of this stuff running on your local like personal computer, because it's so easy to come in here, pull down Docker image, start it, you have a running RabbitMQ server, and then just spin up a couple APIs that you can just do testing with, because the actual code to make this is not a lot. And MassTransit is such a powerful library; it allows you to do this pretty seamlessly. So again, here's just some basic configuration that I have set up. That consumer is right here, and what is I happen to be using raw JSON, so I just have to flag a couple things. But I have a receive endpoint set here. That's what you saw, and then the consumer is registered. So it's not a lot of code, but it's super helpful for like prototyping and just experimenting with things. If you already have like kind of a shell that you can just kind of jump in quickly and experiment with stuff. If you don't have that and you have to routinely set up new things and do all this code, then it might, that might inhibit you from trying a lot of things that you could be trying or experimenting with. Yeah, so that's really all I had. I think it's pretty interesting and pretty powerful code that you kind of get for free and you don't have to do a lot of setup with. So yeah, let me know what y'all think, and I'll see you in the next one.